Hey, it's Doc Williams, and we're going to write chemical formulas for binary ionic compounds and ionic compounds with polyatomic ions. When writing chemical formulas for ionic compounds, you want to make sure that the overall charge for the compound is equal to 0. What this means is that all of the charges for your cations have to be balanced out by the charges of the anions. For example, if you have a total positive charge of 2, then you need to have a total negative charge of 2 in order for them to cancel out and the overall compound to equal 0. To do this, I used the swap and drop method, also known as the crisscross method. First, we will determine the ionic charge for each of the elements in the ionic compound. The first element is sodium. This is in group 1, so it will have a positive 1 charge. The next element is chloride, and when we have an ending of IDE, we know that it is a single atom ion or anion, in this case chlorine. And since it's in group 17, it wants to gain 1 valence electron, and it will have an overall charge of -1. Normally, we do not have to write the 1s in front of the charge if it's a 1, but I want to do it here so that you can see what I mean by drop and swap, or swap and drop. So we will take the charge only, not the symbol, but the charge only of the cation, and use that as the subscript of the anion. And we will do the same thing for the anion. This will now become the subscript for the cation. When we write the chemical formula, Na1Cl1, and when there is 1 and or when both of the subscripts are the same, then we could simply write it as NaCl. It's understood to be 1 there. The last step you want to do is to double check your charges to make sure that the overall charge for the compound is 0. So sodium is a positive 1. We can add that to chlorine, which is a -1 charge, and this will equal 0. So we're good. The next example is barium phosphide. The first element, barium, is in group 2. It has 2 valence electrons, will lose those 2 valence electrons and form a 2 positive cation. The second element is phosphide. And since we have that IDE ending, we know that this is not, well, 9 times out of 10, not a polyatomic ion. And if you are confused on the polyatomic ions, please watch the video where we talk about how to name them. That will help you determine the difference between an anion, a monatomic ion, I should say, a monatomic ion and a polyatomic ion. So this is going to be phosphide, and this has a 3 negative. It is in group 15, has 5 valence electrons, and therefore it wants to gain 3 in order to make that full octet, which will give it 3 more negatives than positives. So let's do the drop swap. We're going to take this 2, swap it, and then use it as the subscript for P. And we're going to do the same thing for the, notice I'm taking the number only, swap and drop it. And then we're going to use that as the subscript for barium. When we write this, we will have barium (3) phosphide 2. Let's do a quick check of the math. So we have 3 times the 2 positive charge of barium plus 2 times the -3 charge of phosphide. That would give us a +6 plus a -6, and that would equal 0. So we are balanced. Our overall charge is 0. Let's look at our next example of magnesium oxide. Magnesium is in group 2, so we have a 2 positive charge. Oxide, or oxygen, is in group 16. It wants to gain 2 more valence electrons, which would give it an overall 2 negative charge. Using the drop swap, we have the 2 from the magnesium being a subscript for the oxygen, and the 2 from the oxygen being a subscript for the magnesium. When we write this, we have magnesium 2 and oxygen 2. Since both of the subscripts are the same, we do not have to write the subscripts. It's a 1-to-1 ratio. What we can do then is just write it as magnesium oxide, just as we did with sodium chloride. If we do a quick check of the charges, we will have a 2 positive 2s plus 2 negative 2s, which would give us +4 plus -4, which would give us an overall charge of 0. Pause the video and practice these 3 yourself. Calcium is in group 2, which will have a 2 positive charge. And bromide, which is bromine, is in group 17, which will have a 1 negative charge. I'm going to include the 1 there. So if I would take this 1 and use it as a subscript for the calcium, and the 2, use that for the subscript for bromide, we will have CaBr2. If we do a check, we have 1 positive 2 plus 2 negative 1s, and then that would give us an overall charge of 0. So our chemical formula for calcium bromide is CaBr2. Potassium is in group 1, so it will have a 1 positive charge. And chloride, or chlorine, is in group 17, and we know that this has a 1 negative charge. If we were to use our drop swap method, each one will have a subscript of 1. To have an overall charge of 0. Now let's look at magnesium fluoride. Magnesium is a group 2 element, a 2 positive charge, and fluorine is a group 17 element with a 1 positive charge. a 1 negative charge. So our 1 will become the subscript for magnesium, and the 2 will become the subscript for fluorine. In this case, we will have Mg. That will be Mg1. We do not need to write anything there. And F2. We do a quick check. We see that we have 1, 2 positive plus 2 negative charges, which will give us an overall charge for our compound of 0. The next set of examples will be working with polyatomic ions. You should have a list of these or have memorized these at this point, but it's okay to have a list. So we're going to follow the same steps, use the swap drop method, and In some cases, we will have to use parentheses in order to show how many of the entire ions that we have. Beryllium is a group 2 element. It has a 2 positive charge, while sulfate is something we have to memorize. This has a negative 2 charge. We use our drop swap. We notice that this follows the rules of magnesium oxide that we saw with magnesium oxide. When we have two or both of our subscripts being the same, then we can simply write it without the subscripts. You will still include the 4 for a sulfate because that is part of the sulfate polyatomic ion. This is one full unit for this polyatomic ion for every beryllium. Let's look at the next example of calcium. Calcium, also a group 2, has a positive 2 charge, but phosphate has a negative 3 charge. We use our drop swap here. Now for this, we will write calcium 3 and PO3, we need to make 2. In order to show that we have 2 PO3s, 2 phosphates, we need to put a parentheses around this and then make our subscript outside of the parentheses of 2. What that does is that tells us that everything inside of the parentheses is doubled. So let's do a quick math check here. We have 3 positive 2s and we have 2 negative 3s. So positive 6 plus negative 6 will give us 0. This is our chemical formula. For sodium hydroxide, Na, we know that this is a +1, and then hydroxide is OH, -1. We do our drop swap, and in this case, we have the same subscript, so we do not need to write them, and this becomes sodium hydroxide, NaOH. If you notice, it's easy to tell that you have a polyatomic ion when you are looking at the chemical formulas because you have 2 capital letters next to each other. Anytime you see a capital letter, that is indicating that you have a new element. Beryllium, capital B, lowercase e, that's one element. Calcium, capital C, lowercase a, one element. However, a capital P, capital O, that lets you know you have more than one type of element in that ion. Pause the video and write the chemical formulas for each one of these. We have beryllium, 2 positive, and acetate, which is C2H3O2, 1 negative. A drop swap. Would give us Be C2H3O2, and because we have 2 of these, we're going to use our parentheses 2. I'm going to put my 2 there. So let's look at the next one, sodium carbonate. Sodium +1 and carbonate is a -2. Drop swap, Na2, CO3. Potassium has a +1 charge, and cyanide, which is capital C, capital N, has a -1 charge. If we follow our drop swap, we see that both of these will have the same subscript. So we follow the rule where we will write them without a subscript. Let's do some mixed practice. The purpose of this one is to distinguish between binary ionic compounds, meaning you have two monatomic ions, and ionic compounds that contain polyatomic ions. The first one is aluminum sulfide. We have IDE, which indicates that this is going to be a monatomic ion. Aluminum is in group 3, so we have a 3 positive, where sulfide is in group 16, and we will have a 2 negative. That should be a negative. So if we use our drop swap, then we see that we will have aluminum 2 and sulfur 3. Calcium perbromate, ATE, anytime you see an 8 or an ite, that's a clear indication that you probably want to go and look at your polyatomic ion sheet. So in this case, calcium, group 2 plus, and perbromate is Br04 negative. And remember, when this only the sign, then it's understood to be 1. We're going to switch these out. And therefore we have calcium. And since we have 2 of these, we need to use our parentheses and put the 2 on the outside to indicate that we have 2 complete polyatomic ions in this compound. Our next example is magnesium sulfate. And if we look and see 8 ATE, that is an indicator that we're going to use our polyatomic ion table. Magnesium is in group 2, so we have a 2 positive charge, and sulfate, SO4, with a 2 negative charge. We already see that when we do our drop swap, that the subscripts will be the same, so we will just write magnesium sulfate. In summary, when writing the chemical formulas for ionic compounds, you want to first determine the ionic charge for each ion in the compound, then use the swap drop method to determine the subscripts. You want to swap just the ionic charge itself, the number, not the positive or negative, just a number, and then use that number as the subscript. Use parentheses if there is more than 1 polyatomic ion. No need to use that with monatomic ions, only polyatomic ions. And check that the overall charge of the ionic compound equals 0. I hope this helped, and don't hesitate to reach out with any questions.